All right, so let's add in a little bit more understanding, kind of with what we were just talking about with the sine, cosecant, cosine, secant, tangent, and cotangent. Um, so we've got the angle measures and those ratios. Hopefully you got a little bit of understanding about that now. And let's kind of play that out. What's that mean in terms of practicality and of using them? So tangent, if we're going to talk about the tangent of theta, that's going to be the sine of theta, which is our y value, divided by the cosine of theta, which is our x value. And that's where this piece here comes from. So tangent of theta is going to be sine over cosine, or the y divided by the x. Okay. Now the cotangent, remember that's we're talking about the reciprocal of this. So it is the reciprocal of tangent. So one cotangent is equal to 1 divided by tangent. Remember what tangent is? Tangent is the sine divided by cosine. So I think if we had 1 divided by tangent, but tangent is sine of theta divided by cosine of theta. Well, how would we get rid of this denominator here? We'd multiply by cosine of theta over sine of theta, both on the bottom and top of our fraction here. So cosine of theta, sine of theta on both. Here, sine of theta divided by sine of theta is 1, and cosine of theta divided by cosine of theta is 1. And 1 times cosine of theta over sine of theta gives us cosine of theta over sine of theta. And that's, so cotangent would be equal to, in terms of our x and our y, would be cosine, that's our x value, divided by y, our sine of theta value. All right, secant. Remember that secant is the reciprocal of cosine. And cosine, so that's going to give us 1 over cosine if it's the reciprocal. And so cosine now becomes the radius over the x value, rather than the x value over the radius. And so from here we'll have secant is equal to 1 over cosine. Likewise, and real similar, the cosecant, that's the reciprocal of the sine, is going to be 1 over sine of theta. And so kind of the same idea is in play. Now, the other thing that needs to be taken into consideration now, we noticed this when we went through the tangent graph, or tangent table in the last lesson. But when for tangent, when the x value, because remember opposite over adjacent, so when that adjacent side, its value is 0, that we ended up with undefined. And so we can't have the x, or the denominator here for tangent, being equal to 0. When we do, it's undefined. And now that we're getting all of these reciprocals, places where we've had 0 in the numerator, but it hasn't made a difference, for example, sine and cosine, you can have a 0 value for both of those, and it's not a problem, it's just 0. But now that we're having the reciprocal, now those 0 values are going down into the denominator. So any point where the cosine would give you 0, now that's giving you an undefined, and so just be careful for that. So when secant, when that x value, or secant is the reciprocal of cosine, so when the cosine value of theta is equal to 0, then our secant is going to be undefined. Likewise, when our sine value, sine of theta is 0, then our cosecant is going to be undefined because that 0 is now in the denominator. Same thing with a tangent. For a cotangent, whenever the y value in tangent is 0, now that cotangent has moved the y value down to the denominator, also giving us undefined when that happens. So just be aware that for all 4 of these, I was going to say just the 3 reciprocal values, but tangent included, actually, we have to be much more careful about when will we have maybe an undefined as a possibility. When are we going to have 0 in the denominator? So keep aware for this. Be aware of it, that this is a possibility, and as long as you're doing that, then I'm sure you guys are going to do great. All right, hope that helps.